Alright, well today we're going to be solving quadratic simultaneous equations. This is normally kind of a harder topic when it comes to GCSE questions, and they build on simultaneous equations. So you have to remember, simultaneous equations are equations that can have only the same values of x and y at the same time. The difference with quadratic simultaneous equations, you can either have two solutions, one solution, or no solutions. Now generally they'll use the equation of circles, as you can see on the screen here. Now the cases for where you get 2, 1 or 0, we'll see right now. If we were to draw set axes with a circle, let's say we have a straight line, there are three different ways we get this. We could have one here where there are two solutions. We could have one here where it only touches once, or here where it touches it no times. So just be one, just in case you only get one solution, that's a viable answer as well. So just something to look out for. So, how are we going to solve this? Well, normally when we solve simultaneous equations, we always try and get rid of one of the variables. The problem here is we're dealing with quadratics, so we can't have the same coefficients in both equations. What we want to do is we want to substitute the equation with the lower power into the higher one. So if we label them 1 and 2, I want to substitute equation 2 into equation 1. Well, it's already given me it in a form that I can substitute it straight in. So I can just replace the x with this equation here. So instead of an x, I now have a y minus 5 squared plus y squared is equal to 30. If you expand the y minus 5 squared, you'll get y squared minus 10y plus 25 plus the other y squared equals 30. If we simplify this, we have 2y squareds minus 10y. I've got a 25 here. I want to take away the 13 because I want to get a 0 on the right hand side so that I can solve the equation. So 25 minus 13 is a plus 12. You should be able to spot that if I divide everything by 2, it will make the factorization easier. So I could simplify that to y squared minus 5y plus 6. So here we're looking for the factors of 6 that give us minus 5, which will be minus 3 and minus 2. So you've got a bracket of y minus 3 and then a bracket of y minus 2. That means your solutions for y are going to be y equals to 3 or y equals to 2. Now we're almost there. What we just need to do is we now need to find x by substituting these back into equation 2. So if we know that y is equal to 3, we've got 3 minus 5, which is minus 2. And if y is equal to 2, that's 2 minus 5, which is minus 3. Just get rid of that y and turn that back into an x. So now you have your two sets of solutions, 3 minus 2 and 2 minus 3. Now we'll move on to an example where y and x aren't already rearranged for us. So once again you want to label them 1 and 2. You want to ideally substitute equation 2 into equation 1 to get rid of one of the squares. Problem is we don't have an x or y equals. With this one you can choose which one. I feel it would be easier to do x equals since that's already positive. So I can rearrange this to get x is equal to 2 plus y. Then I'm going to substitute that in here. So I'm going to get 2 plus y squared plus y squared is equal to 34. If we expand, we get 4 plus 4y plus y squared plus y squared is equal to 34. If we simplify, we get 2y squared plus 4y. We've got 4 minus 34, which is minus 30. Once again, in this case, we can divide by 2. This won't always be the case. You want to make sure you're doing it correctly. So now we want to find the factors of minus 15 that will give me a positive 2. That will be 5 and minus 3. We've got y plus 5, y minus 3 is equal to 0. So y is going to be equal to minus 5 or positive 3. Once again, to find x, we substitute into this equation here. So for a value of minus 5, x is going to be equal to 2 plus that. So that's 2 minus 5, which is minus 3. For a value of 3, x is going to be equal to 2 plus 3, which is 5. And these are two sets of solutions to that simultaneous equation. So these are the points where the line equation will go through the circle at two different points. Let's try a hard example here. So as you can see, this question wants you to give your answers to three significant figures. So you know when you factorize, you'll probably have to use the quadratic formula. Now what we notice about the second equation, we've got a 2x this time. So it might be easier if we make y the subject of the formula. When we do that, we'll get y is equal to 2x minus 3. Then we'll put that into the first equation here. So you have x squared plus brackets 2x minus 3 squared is equal to 27. If we expand, we get x squared plus 4x squared. So we've got minus 6x, which is minus 12x, plus 9 is equal to 27. So once again, we're going to simplify. We've got 5x squared minus 12x, 9 take away 27, it's going to give you a minus 18. So at the moment we can't divide by anything. There are a couple of different ways to do it depending on what sort of paper this turns up on. But because it's a three significant figures question, we know it's going to be a calculator paper, so using the quadratic formula will be easiest. So once again, remember the quadratic formula is minus b plus minus the square root of b squared minus 4ac over 2a. So let's substitute our values in. Our value of b is minus 12. So minus 12 is going to be a positive 12 plus minus the square root of minus 12 squared minus 4 lots of a, which is 5, and c, which is minus 18, all over 2 lots of a, which is 5. Now you get two solutions, a positive and negative solution, when you plug this into your calculator. So let's do that right now. So for the value of x, because they wanted it to three significant figures, we get a value of 3.44 for the positive value, and then for the negative value, we'll get a value of minus 1.04. So we're almost done. We just need to once again substitute these back into the original equation, which was y is equal to 2x minus 3. So for this value of x, you get a y value of 3.88, and then for this value of x, you get a y value of minus 5.08. And those are rounded to three significant figures, and those are my two sets of solutions. Make sure to write them separately, especially if it asks you to write them as coordinates. And the final example we're doing, this one will be dealing with fractions, which is quite a bit harder. So it doesn't really matter if we make x or y equals in the second equation, we're going to have a fraction both ways. So I prefer to deal with the y equals. So if we rearrange this, we get 2y is equal to 3 minus 3x. So if we divide both sides by 2, y is equal to 3 over 2 minus 3x over 2. And we're going to be substituting that in here. So we have 2x squared minus brackets 3 over 2 minus 3x over 2 squared equals 14. Now for this case, let's write it as a double bracket to make sure we're not making any mistakes. So you want to leave everything inside the negative because you want to deal with the minus at the end. 3 over 2 times 3 over 2 is 9 over 4. Then 3 over 2 times minus 3 over 2 is minus 9x over 4. Then you have another minus 9x over 4. Then you have a plus 9x squared over 4, all equal to 14. So now let's deal with that negative. So this becomes 2x squared minus 9 over 4. These two become, let's just change that to a 4. These two become minus 18x over 4s. With the minus now becomes a plus 18x over 4. And minus 9x squared over 4, which is equal to 14. So let's try and simplify some things. First, let's times everything by 4 to get rid of those denominators. So 8x squared minus 9 plus 18x minus 9x squared is equal to 14 times 4, so double 28, which is 56. Next, we want to try and rearrange things so we have the x squareds on one side. 8x squared minus 9x squared will give me a minus x squared plus 18x minus 9 equals 56. I want to get a positive x, so I'm going to take everything to the right hand side. So if I add the x squared, I get a positive x squared. I then get a minus 18x, and then I'm adding 9, so that's a plus 63. No, sorry, plus 65. So we check, do any factors of 65 give me minus 18? We know we're going to be looking for negative factors. So 1 minus 65, 3, 4, 5, and minus 13. Yep, minus 5 and minus 13 work. They'll give me minus 18. So let's write our factorized form. So you've got x minus 5 brackets x minus 13 is equal to 0. So you know x is equal to 5 or x is equal to 13. And once again, we just need to find our original values of y. So our equation was 3 over 2 minus 3x over 2. So if we substitute 5 into that equation there, we'll get a value of minus 6. Then, if we substitute 13 into that equation there, we get minus 18. And those are my two solutions for x and y. And once again, depending on what paper this turns up, you might have to use your factorization methods or complete the square. Or if it's on a calculate paper, it's best to use quadratic formula to avoid making any mistakes. Just be careful what degree of accuracy they want you to round it to. And the most important part is, as soon as you can rearrange the first equation correctly at the top here, the rest of it should be easy enough. Hopefully that cleared up a lot of things about quadratic simultaneous equations.